Alrighty, this is Algebra 2, the Chapter 1 review. I'm going to be doing the odds. So, if you're having a problem, even if it's with the evens, go to one of the odds next to it. And watch it. Watch it as many times as you need to get what it is that we're doing, and go from there. So, on these first group, what we're doing is simply going from a written description of an expression to the actual algebraic expression. So number one, we're going to look at the word quotient. So that's going to be division. And then what are we dividing? We're dividing a number. Let's call that x. You can really call it anything you want. And 4. Okay. So that's the quotient of a number in 4. We now have is greater than. So we put that right there, the greater than, the inequality sign pointed the right way. 35. There you go. That's it. That's your answer. Now, you can also put for division, you can put x over 4 is greater than 35, and that works too. So, number 3, a number. Let's use x divided by 8, pretty straightforward, is equal to, boom, boom, 39. And that's it. Again, with division, you can use that as well. On to number 5. So number 5, we're going the 9th power of u, so that's u to the 9th. That's it. 7, the 8th power of x is equal to 33. Again, we're just going straight forward. 8th power of x is equal to 33. So now for number 9, we want to switch it up a little bit. Write as a verbal expression. So we have u minus 12. A lot of different ways you can put this. You can put the difference of u and 12. U minus 12 for this first one, I simply put 12 less than a number. So 12 less than a number is going to be u minus 12. On to 11. I just went 6 more than a number. You could just write down 6 plus n plus 6, a number plus 6, the sum of 6 and a number. And for 13, I'm going to go the difference of 23 and a number, and 11, okay? So again, so notice here, same type of question, different approach, either one of those is fine. So moving on to number 15, so we have r over 16 equals 20. We're solving an equation, so we want to isolate the variable. We want at the end it to be variable equals something. So here we have r divided by 16 equals 20. So to get that variable by itself, what we want to do is we want to do the inverse operation. So because it's r divided by 16, we want to multiply by 16. That cancels out the 16s because 16 divided by 16 is 1. 1 times r is r. So now we've isolated that variable. On the other side, gotta do it. Golden rule algebra. Do it to one side, gotta do it to the other. So you have 20 times 16, so you end up with r equals 320. We have 13 plus a equals 6. So the 13 and the a are combined by addition, so we want to use subtraction. Do it to one side, gotta do it to the other. So we have a equals negative 7. 19 is now a two-step problem. We want to get rid of that 1 first, so we're going to add 1 to both sides. And we get p over 2 equals 3. It's p divided by 2, so in the inverse operation, we want to multiply by 2. That's going to give us p equals 6. 21, We have negative 7 plus 2x. So we're going to add 7 to both sides. That's going to give us that 7 minus 7 is 0. 0 plus 2x is 2x. Negative 39 plus 7 is negative 32. Now we have 2 times x, so we want to divide by 2. So now we have x equals negative 16. And that's it. 23. So we have negative 17 equals negative 8 plus 1. So we're going to treat that negative out front kind of like a negative 1. Okay? So it's negative 1 times a plus 1. So we're going to divide by a plus 1. So we're going to divide by negative 1. That's going to give us a plus 1 on that side. And negative 17 minus 1 is going to give us 17 on the other side. So now 17 equals a plus 1. We're going to subtract 1 from both sides. And we're going to get 16 equals a. Now, it's possible that you distributed that negative first and then solved. And you're going to get the exact same answer. You'll still get a. When you end up solving for a, you're still going to get a equals 16. So on 25, I want to do this 2 different ways. I just described how you could, on 23, you could either divide by negative 1 or distribute. So on 25, I'm actually going to do it twice. Once with distributing, once with dividing by 3. I'll show you that it doesn't really matter. So we're going to start off with distributing. So 3 times 7n is 21n. 3 times negative 7 is negative 21. So now what we're going to do is we're going to add 21 to both sides. And we get 21n equals negative 63. When I divide both sides by 21, I get n equals negative 3. Okay. So if I do it the other way, if it's the same, I should end up with n equals negative 3. If I divide by 3, I get 7n minus 7 equals, now the reason I can do that is because over here, when 2 things are next to each other, that's multiplication. So I can work on freeing up that n by, if it's something is attached to or near the variable with multiplication, I divide. So I end up with 7n minus 7, and then negative 84 divided by 3 is negative 28. I'm going to add 7 to both sides, and I'm going to get 7n equals negative 21. Divide both sides by 7, and lo and behold, I get n equals negative 3. So again, either way you do it is fine. I'd figure out which way you like better, and just go with it that way. Now remember, this can only work, so 25, 27 it works, 29 it won't, and we'll get to why that won't work. So 27, we have 4 plus 1, we have negative 92 equals 4 times 1 plus 3x. I'm going to divide by 4. Negative 92 divided by 4 is negative 23. Negative 23, we're going to say equals 1 plus 3x. We're going to subtract 1, and so we get negative 24 equals 3x. We're going to divide both sides by 3. We get negative 8 equals x. So again, what we're doing is working on isolating that variable. And how we do that is we take everything that's on the same side of the equal sign as it is, the same side of the equation, and we move it to the other side of the equation using the properties of equality. First, the division property of equality to get rid of the times 4. Then the subtraction property of equality to get rid of the plus 1. Then finally, the division property of equality again to get rid of that times 3. And that's going to give us x equals negative 8. And when we look at 29, notice that we have an x inside the parentheses and an x outside the parentheses. So here we can't really divide by negative 7, because if we did, we'd end up with some really funky numbers, like negative 6/7 and equals 21. Just fractions, and fractions are bad. So what we're going to do is we're going to go ahead and we're going to distribute. So we have negative 147 equals, negative 7x minus 56 minus 6x. So I distributed that negative 7. Now we're going to combine like terms. That negative 7 and negative 6x. So we get negative 147 equals negative 13x minus 56. We're now going to use the addition property of equality, which says we can add the same amount to both sides and keep it equal. And we get negative 91 equals negative 13x. When I go ahead and divide both sides by 13, I get 7 equals x. And that's a positive 7 because I have a negative divided by a negative. Okay, everyone's favorite, absolute values. So whenever you have an absolute value, you're going to have to do it twice. The first time, you're just going to write the equation exactly as it is without the absolute value bars. Okay? Second time, you are going to write it the same, except on the other side of the equal sign, the other side of the equation, you want to make it negative. Now, if that's just a 14 over there, great. If that's a 14 plus 5x, then I want to make that whole thing a negative. I change the sign of the entire side, not just the lead term. So over on the left-hand side, I'm going to add 5 to both sides, and I get x equals 19. Now notice that because it's absolute value, that as long as that term inside the absolute value is 14 away from 0, this is going to be true. So it's true for negative 14 and positive 14. So we're going to have an and here. Both of these answers will make this true. We add 5 both sides over here, and we get x equals negative 9. So when x equals 19 and x equals negative 9, that's a true statement right there. 33. So again, we have the absolute value of r over 4 equals 1. So to break it out of those absolute value bars, we want to write r over 4 equals 1. First time, you just want to write it exactly the same without the absolute value bars. Then on the other side, we want to go r over 4 equals negative 1. All we do is we multiply both sides by 4. So we get r equals 4 and r equals negative 4. Okay. Now 35 is a little bit different because 35, notice, unlike 33, we're not starting off with the absolute value by itself. Okay. So to break out the absolute value bars, the absolute value portion of the problem needs to be all by itself on one side of the equation. So when we look at number 35, we see that the 10a, the absolute value of 10a, is not all by itself. Rather, it's got that negative 9 out front. So when two things are right next to each other without a sign, we assume multiplication. So we have negative 9 times the absolute value of 10a equals negative 90. So we're going to divide both sides by negative 9. That's going to give us the absolute value of 10a equals 10. Now that the absolute value is all by itself, we can break it out. We write it just the way it is, 10a equals 10, and then we go 10a equals negative 10. So for both of these, to get a by itself, all I have to do is divide by 10. And that's going to give me a is 1 and a is negative 1. Okay, so notice here that we have 2 answers again. So 39 is a little bit trickier. We have 2 operations that we need to get rid of before we have the absolute value all by itself. So we have that negative 8 and then the 4. Well, how do we move a negative 8 away from the variable? We're going to add 8. So that's going to give us 4 times the absolute value of 7n minus 6 equals 24. So now we got to get rid of that 4. So we divide by 4. And we end up with the absolute value of 7n minus 6 equals 6. So we're going to break that out. First things first, we're going to write it just the way that 7n minus 6 equals 6. Secondly, we're going to write it 7n minus 6 equals negative 6. So starting over here at the 7n minus 6 equals 6, we're going to add 6 to both sides. And we get 7n equals 12. Now immediately you look at that and you go, no, maybe I did it wrong. 7 and 12 aren't equally divisible. Well, trust your math. We're going to divide both sides by 7 and we're going to get n equals 12 sevenths. When I do it over on the right-hand side, I add 6 to both sides, and I get 7n equals 0. Divide both sides by 7, and I get n equals 0. So when I do this, now I have n equals 12 sevenths and n equals 0. And those seem like weird numbers. So I actually want to go back and I want to check. How I'm going to check is I'm going to take that 12 sevenths, and I'm going to plug it in right there for that n. Now notice here, if I go 7 times 12 sevenths, the 7s are going to cancel out. Because 7 divided by 7 is 1. 12 times 1 is 12. So that's going to give me 12 minus 6 inside the absolute value bars. Well, 12 minus 6 is 6. 6 times 4 is 24. And 24 minus 8 is 16. So that actually does check. But whenever I get a number like 12 sevens, I'm probably going to want to go back, double check my work, plug it in, make sure it works. You can do that with 0. 0 times 7 is 7. Or, sorry, 0 times 0, 0 times 7 is 0. 0 minus 6 is negative 6. The absolute value of negative 6 is 6. 4 times 6 is 24. 24 minus 8 is 16. So that helps as well. Okay, on to 41. And again, we have 2 operations here. If at any point this is going too fast, feel free to rewind it. Watch it again. Unfortunately, again, you can slow it down maybe. And just laugh at my voice in slow-mo if you really want to. So 41, we have 7 times 8 plus 10x, the absolute value thereof, plus 7 equals 91. So we're going to start off by subtracting 7 from both sides. That's going to give me 7 times the absolute value of 8 plus 10x equals 84. We're going to divide both sides by 7. So we get the absolute value of 8 plus 10x equals 12. So now that we have the absolute value isolated on the left side of the equation, we can break it out. First, we write it just the way it is. 8 plus 10x equals 12. And then we write it as 8 plus 10x equals negative 12. So we're going to follow now to isolate the x because we have 8 plus 10x on both sides. We're going to start off by subtracting 8. So we're going to get 10x equals 4. We're going to divide both sides by 10, and we get x equals 2/5, or 0.4. Either one of those is fine. We repeat the process, subtract 8, and we get 10x equals negative 20. Divide both sides by 10, and we get x equals negative 2. Now again, because remember, absolute value simply relates to how far a number is away from 0. So when we have right here 8 plus 10x, the absolute value, equals 12, that's true whenever 8 plus 10x, the answer to that is 12 away from 0. So that's when that is equal to positive 12, because 12 is 12 away from 0, or negative 12, because negative 12 is 12 away from 0. That's why we have those two answers, and both are true. So what we need to do on these next one, these are called literal equations, and what we need to do is we need to solve for the given variable. So this is actually an extremely important skill, and is really helpful for when we're doing later equations and we need to solve for a specified variable instead of kind of what the equation is normally set up for. So if we look at 43, we have z equals ma plus b. We need to solve for a, so we need to isolate that a right there. Well, that a is not by itself. It's got that m and that b. We want to work outside in. So how do we get rid of that b? How do we move a plus b from one side to the other? We subtract it. So now we have z minus b equals m times a. Because we have m times a, we're going to divide both sides by m. And we're going to get z minus b over m equals a. We've now isolated our variable, so that's our answer. Same idea for 45. We have k plus a minus b, and we're solving for a. We're going to add b to both sides, so we have u plus b equals k plus a. We're then going to subtract k from both sides, and that gives us u plus b minus k equals a. See, all we're doing is applying our rules of math to an equation with no numbers. 47. Okay, so 47, we're now dealing with inequalities. So inequalities, when we're solving them, we basically want to treat the inequality like an equal sign, like an equal sign, like an equal sign. The main difference being that whenever we divide or multiply by a negative, we switch the sign. So here on 47, we're going to dive right in with that. The first thing we got to do is we got to divide by negative 8. Now again, you could distribute and solve that way, and you're going to get the same answer. Dividing by negative 8, we get negative 4 plus 6r, and I switch the sign because I divided by a negative. Okay, the actual number, in order to switch the sign, the actual number that's doing the dividing, the actual number that's doing the multiplying on both sides has to be the negative. So here we're dividing by negative 8, so that fits the bill. And we have negative 4 plus 6r is less than or equal to 14. We're going to add 4 to both sides, and we get 6r is less than or equal to 18. Divide both sides by 6, and we get r is less than or equal to 3. So when we plug that back in, we're going to do a closed circle, arrow heading left. Why? Well, it's a closed circle to indicate that 3 counts. If I plug 3 back into that equation, I'm going to end up with something like negative 112 is greater than or equal to negative 112. And that's true because it's or equal to. Now here, because it's less than, because the little arrow is pointing at my variable, I want to do the arrow to the left. 49. Here we're going to have to distribute. So we're distributing a negative 8 across. So we end up with negative 85 less than negative 7x. And then we're going to go negative 8 times negative 5 is plus 40. And negative 8 times negative 4x is plus 32x. We're going to combine like terms, so we have negative 85 is less than 25x plus 40. So to get the 25x, we want 32 minus 7. We're now going to subtract 40 from both sides, and we get negative 125 is less than 25x. Divide both sides by 25, and we get negative 5 is less than x. So that's the same thing as x is greater than negative 5. So we put an open circle at the negative 5, and because x is greater than that, we put the arrow heading left, or right, sorry. It's late. It's like almost 2 o'clock. So, okay, moving on, number 51. So here we have 2 distributions. So we're going to distribute the negative 3 to that first parentheses and the negative 6 to the second. So we have negative 6 is greater than negative 9 plus 6x minus 6x plus 36. So notice here, we're going to get negative 6 is greater than, and then the 6x's cancel out. So we have 6x minus 6x. That's 0. So then we have negative 9 plus 36, or 27. So that leaves us with negative 6 is greater than 27. Well, when is that true? That's never true. So this is going to have no solution. Looking at number 55, we're going to distribute again so that second negative, we're going to act like a negative 1. So we have negative 2 times n is negative 2n. Negative 2 times negative 2 is a positive 4. Negative 1 times negative 8n is a positive 8n. Negative 1 times 1 is a negative 1. Is greater than or equal to, and then we got everything over there. Now notice what I did. I went 8n plus n is 9n, and 2 plus 1 is 3. So I'm going to combine like terms on the left side of the inequality. 8n minus 2n is 6n, plus 3, 4 minus 1, is greater than or equal to 9n plus 3. I'm going to combine my variables. So I'm going to subtract 6n from both sides. And I get negative 3 is greater than or equal to 3n plus 3. I'm going to subtract 3 from both sides now. And I get negative 6 is greater than or equal to 3n. Divide both sides by 3. And I get n is less than or equal to negative 2. Okay? So, that means I'm going to put a closed dot on negative 2. And because n is less than that, arrow going to the okay. 57. I'm going to distribute that 7 and distribute that negative 2. So I have distribution on both sides of the inequality. So now 7n minus 28 is less than negative 2 times negative 7, positive 14. Negative 2 times negative 2n, positive 4n. Combine my variables. I'm going to subtract 4n from both sides. And I get 3n minus 28 is less than 14. I'm going to add 24 to both sides. And I get 3n is less than, I'm adding 28 to both sides. I don't know why I said 24. And I get 3n is less than 42. Divide both sides by 3. And I get n is less than 14. So no or equal to. So the 14 doesn't count. I put an open parenthesis. And I move it to the left because n is less than that number. So, starting at 58, we have compound inequalities. Well, what does that mean? It means it's either going to be an and or an or. It means that we're either going to have arrows pointing at each other or arrows pointing away from each other. If they're pointing at each other, we connect the lines. If not, then if they point at each other, it's an and. Okay, because numbers can be greater than 3 and less than 6. If they're pointing away from each other, they're an or. So if we use 3 and 6 again, it would be x is less than 3 or greater than 6. Okay, it can't be both. It can only be one. So, for 59, what we want to do is we're actually going to do both of them separately and graph them both separately. This is an or right there. So we should see that pointing opposite ways. So for the 8p plus 1 is less than negative 55, we're going to subtract 1 from both sides. That's going to give us 8p is less than negative 56. When we divide by 8, we get p is less than negative 7. So we graph that. Open circle, arrow to the left. We're now going to do negative p minus 6 is less than negative 8. We're going to add 6 to both sides, and we get negative p is less than negative 2. And then we're going to multiply both sides by negative 1. Now notice when we multiply both sides by negative 1, we flip the sign. So now we have p is greater than 2, and we graph that. Open circle, and arrow to the right. 61, again we have an or. So we're going to have the arrows pointing opposite. If you ever have an or and they're pointing at each other, probably did something wrong. If you have an and they're pointing away from each other, probably did something wrong. So make sure that your answer makes sense in light of what we're doing. So we want to go subtract 9 from both sides. We get 8x is greater than or equal to 32. Divide both sides by 8, and we get x is greater than or equal to 4. So we're going to graph that. Close circle because it's greater than or equal to, arrow to the right because it's greater than. Add 8 to both sides. We have 5x is less than or equal to negative 50. Divide both sides by 5, and we get x is less than or equal to negative 10. So again, it's less than or equal to, so we're going to go a solid dot on 10, arrow to the left. We have arrows pointing away from each other, which is good for an OR problem. On to 63. So here, notice that it's just one big thing, so we're actually going to graph them both on the same thing, but we want to break apart. We want that middle part to go with the left and then the middle part to go with the right. And that's the easiest way to write this. So notice I used a red circle and a blue box to separate them. And I'm going to write them separately. Whoops. So I'm going to start off 4x plus 2 is less than 9 plus 5x. I'm going to subtract, and then the other one is 9 plus 5x is less than or equal to 4 plus 4x. Okay? Now this should be an and, but we can never be sure, so just be careful. So we want to go 4x minus 2 is less than 9 plus 5x. We're going to subtract 4x from both sides. So now we have 2 is less than or equal to 9 plus x. So we're going to subtract 9 from both sides, and we get negative 7 is less than x, or x is greater than negative 7. Other one, we're going to subtract 4x from both sides, and we get 9 plus x is less than or equal to 4. I'm going to subtract 9 from both sides, and I get x is less than or equal to negative 5. So I look at these, and can I go, are they both true? Can x be greater than negative 7 and less than or equal to negative 5? Sure. Negative 6 would be an example. So we're going to put a solid dot on negative 5 because it's less than or equal to. And because it's less than or equal to, we're going to have an arrow pointing to the left. And then we're going to go x is greater than negative 7. We're going to put an open circle on negative 7 and an arrow to the right. See how they connect? That's an and. So anything between negative 7 and up to including negative 5 will make that true. On to 65. So this is an and, so they should be pointing at each other. So we're going to start with 10 minus 8p is greater than or equal to 6 minus 6p. We're going to add 8p to both sides. That's going to be 10, is greater than or equal to 6 plus 2p. We're going to add 6 to, or subtract 6 from both sides. That gives us 4 is greater than or equal to 2p. Divide both sides by 2, and I get 2 is greater than p. Other one is we're going to subtract 5p from both sides. That's going to give me 4p plus 3 is greater than 3. Subtract 3 from both sides, and I get 4p is greater than 0, or p is greater than 0 after I divide it by 4. Graph those. I go on 2. P is less than or equal to 2. So I put a solid dot on 2, arrow pointing left. P is greater than 0, so I can combine those two. And that's what it looks like. Now, 67 is an absolute value. So we treat this a lot like we do with an absolute value using an equality, which is we're going to have two answers. The first we break out, and we write it just the same and just like we did with the equality. The second part of it is we're going to write the x minus 7. We're still going to keep that negative 4, but here, in addition to making the 4 a negative, we're also going to switch the inequality sign. So when we break out from those inequality signs, we want to not only change the right-hand side to a negative, but we also want to flip the inequality sign. So here we have x over 7 is less than or equal to 4, or greater than or equal to negative 4. And to solve that, we're going to multiply both sides by 7. So we're going to get x is greater than or equal to negative 28, or x is less than or equal to 28. Plot those there, negative 28, solid dot, positive 28, solid dot, and connect, because that's the way. Again, so x is less than, greater than or equal to negative 28, so we got a negative 28, arrow pointing to the right. Here we have x is less than or equal to 28, solid dot, arrow pointing to the left. They connect, so we know it's an and. On to number 69, almost done, guys. So we have the absolute value of 10x is greater than or equal to 10. Same general idea here. We're going to break it out into 10x is greater than or equal to 10, or 10x is less than, 10x is less than or equal to negative 10. We're going to divide both sides by 10. And we get x is less than or equal to negative 1. Or we divide, and so I put the dot on the negative 1, arrow to the left. 10x is greater than or equal to 10. Divide both sides by 10. And I get x is greater than or equal to 1. And so this would be an or. In order to make that true, the number either needs to be greater than 1. I don't know why it's on 2. We'll put it in the right place. Or less than or equal to negative 1. So you can check this. You can plug a 0 in there, and it won't work. 0 times 10 is 0. Absolute value is 0 is 0. 0 is not greater than or equal to 10, so we're good. Any other number that we put in there that is greater than or equal to 1 or less than or equal to negative 1 is going to make that true. So, 71. We're going to subtract 7 from both sides, because remember, we only can break out the absolute value bars once they're isolated on the side of the equation or the inequality. So here we're going to subtract 7 from both sides. That's going to give us 6 times the absolute value of negative 7m plus 9 is greater than or equal to 54. Divide both sides by 6. Remember, up until the point where we're actually breaking out the absolute value bars, we treat it just the same as we would any other inequality. Divide both sides by 6, and we have the absolute value of negative... keep hitting that wrong jump forward button. Absolute value of negative 7m plus 9 is greater than or equal to 9. So now when we break it out, remember, first things first, we're going to write it just the way it is. Negative 7m plus 9 is greater than or equal to 9. We then write it so that we subtract 9 from both sides. And we get negative 7m is greater than or equal to 0. Divide both sides by negative 7, and we get m is... And because we're dividing by a 0, because we're dividing by a negative 7 here, we get m is less than or equal to 0. Okay? So m is less than or equal to 0. So we're going to put a solid dot on 0, arrow pointing to the left. For the second part, when we write negative 7m plus 9. And remember, here we switch it. Less than or equal to negative 9. So we're going to subtract 9 from both sides. We get negative 7m is less than or equal to negative 18. We're going to divide by negative 7. And because we're dividing by a negative, we switch it once again. So we get m is greater than or equal to 18 over 7. That's about 2, a little bit over 2. 2 and 4/7. So that's our dot right there and off to the right. So this again is an or. 73. Last one, guys. So we have 2 plus the absolute value of 8p minus 3 is greater than 7. Subtract 2 from both sides. And we get the absolute value of 8p minus 3 is greater than 5. To break this out, we write the first one just the way it is. 8p minus 3 is greater than 5. Add 3 to both sides. 8p is greater than 8. Divide both sides by 8, and we get p is greater than 1. Open circle on 1, arrow to the right. 8b minus 3, and then what we're going to do is we're going to flip the sign, less than, -5. We're going to add 3 to both sides. We get 8p is less than -2, divide by 8, and we get p is less than -1/4. Open circle on -1/4, arrow to the right. So as you notice, if we end up with the absolute value is greater than, we end up with things going the other way. And that's how all of these are. So I hope this was helpful. If you need any help with any other problems while I'm gone, drop me an email. I'll try and post. Other than that, I hope you guys all behaved, and I will see you on Thursday.